In this video, we are going to do some dot product practice problems. So we're just going to hop straight into it here. Let's say A equals 3, negative 2, 5, and B equals 1, 4, 3. We want to find the dot product of the two vectors. So what we want to do first is, not a 1. What we want to do first is draw them out, like so. Okay. And then what we do here is we do distributive property. So we would distribute 3 to 1, negative 2 to 4, and 5 to 3. 3 times 1, 3. Negative 2 times 4, negative 8. And 5 times 3, 15. And then it's a matter of adding them together. 3 minus 8, negative 5. Negative 5 plus 15 is 10. And this is the final answer. That wasn't too bad, but we're gonna do a few more here. Here's another problem. Feel free to pause the video so you can attempt this yourself. As previously, we want to write out the vectors as so. Okay, and then what we can do from here, we do distributive property for each value. Negative 5 times negative 2, 10. Negative times a negative gets us a positive. 2 times 1/2, 2 over 2, but that easily simplifies down to 1. Negative 3/2 times 6, negative 18 over 2, but that simplifies down to negative 9. 10 plus 1, 11. 11 minus 9 is 2. And this is the final answer right here. Let's switch things up a bit. So we actually want to solve for the variable x as we do the dot product. And we can see the dot product of A and B already equals 7. So how can we approach this? Well, we know that we could do our typical method of dot product. Do distributive property, x times 2, 2x. 3 times negative 1, negative 3. Negative 2 times 4 is negative 8. And doing the basic math, we get 2x minus 11. Keep in mind that the dot product of A and B is 7, so I'm going to move down here. We want to set 2x minus 11 equal to 7. Add 11 on both sides. These 11s cancel out, and we get 2x equals 18. Divide 2 on both sides. These 2's cancel out, and 18 divided by 2 is 9. So we get x equals 9. And this is the final answer right here. With enough practice, this won't be too bad, but if you weren't able to get this, that's okay. We got a few more. Let's do a problem similar to the previous. My apologies. So, A equals x to negative 1 and B equals 3, 0, negative 4. If A times B equals 5, well, the dot product of A and B equals 5, solve for x. This isn't, okay. So, write out the vectors. Okay, we have them written out. Do distributive property. X times 3, 3x. 2 times 0 is just simply 0. Negative 1 times negative 4 is positive 4. And this would equate to 3x plus 4. And now we want to set 3x plus 4 equal to 5. Subtract 4 on both sides. 4's cancel out. We get 3x equals 1. Divide 3 on both sides. These 3's cancel out. And we get x equals 1/3. And this is the final answer. Let's move on to the next one. Let's check for orthogonality now. If we are given a and b, are they orthogonal? So what does it mean when two vectors are orthogonal? If we are given a and b, we want to compute their dot product. If the dot product of a and b equals 0, that means they're orthogonal. However, if they don't equal 0, that means they are not orthogonal. So hopefully that gives you a good idea. So we're going to hop into it here. So let's draw out our vectors. We got A, and now we want to write out B. Okay, do your typical distributive property. 1 times 2 is 2. 0 times 3, 0. -1 times 2 is -2. 2 plus 0 is just 2. And 2 minus 0 is 0. What this means is the two vectors are orthogonal. So hopefully that gives you a good idea on orthogonality. And yeah, let's move on to the last one. Let's knock out this last dot product problem. Feel free to pause the video and attempt this yourself, as attempting yourself first is the best way to learn. So we have our vectors written out, and we do distributive property, like always. 4 times 3, 12. -1 times -2 is 2. 2 times -5, -10. 12 plus 2, 14. 14 minus 10 is 4. Therefore, they are not orthogonal. But that's going to be all for this simple little video. I hope you enjoyed it, and if you did, feel free to like, subscribe, and hit that bell. And feel free to leave any type of feedback in the comments for future improvements. That's going to be all from me, and I will see you in the next one.